Well, see, let's go again. Please, up to this point, how bearing is gotten. Do you understand this? Yes. That is, that bearing starts from north to be 0, east to be 90, south to be what? And west to be what? North. That means north is also 360. Okay. I just want to take it that I've not done anything here. And I want you to know that this thing I'm teaching you now, this one I said, wind is never at, but wind is always from. That is the first idea you need to put in your head. So if I hear, you can't even say that wind is at a place. Wind is never at a place. Hope you know. Rather, the wind can move maybe from this side to the other side, or maybe from here to here. So anytime you see wind in a question, notice that helicopter is moving, wind is also moving, which means we are talking about two movements there. Anything two movements is talking about relative motion. If I know that, I'll tell myself, okay, let's draft the things I'm given. I am given that I have 0 here for north. Please, if you did not understand this the first time, pay attention now. Now I have 90 degrees for east. I have 180 degrees for south. Shebi? East, I remember west immediately. West. Then I have 270 degrees. That I have for west. That means that here will be 360 degrees, Shebi? I watch now, see. They now told us that the bearing is 150 degrees. That is for this helicopter that is moving. The airspeed is 100 kilometers per hour. And it's on a bearing of 150 degrees. You have the question. I'll simply say, if this is 0 to 90, 90 plus what will give me 150 degrees? 60 degrees. I know it's somewhere like this if you measure it. So that means here is 60 degrees. And, okay, sorry. That means here is 60 degrees. And the total thing I have here is 150 degrees. Okay. If I know that, please notice something. They now tell me that a wind 30 kilometers per hour from a bearing of 080 degrees, from a bearing, that wind is coming from a bearing. This wind, see, this wind has this 30 kilometers per hour. Can they go think first? This one is 100 kilometers per hour. This wind is 30 kilometers per hour, but it is coming from a bearing. If it is coming from a bearing, where is it going to? Where it is going to is this direction. Hope you remember that vector talks about magnitude and direction. Is it not true? So if that wind is blowing, where is this direction? Your direction is not where you are coming from, but where you are going to. Hope you know. So where is it going to? So where it is going to will be determined by its position. So its position is simply from the east. Now see, it is moving from this east, which I can draft. That is not east. See, I have, let me draft this. It is coming from a position. I want to clean this to have more space. You've already written it. I watch. Pay attention. Women do. Pay attention. Watch. See, let's say I have this now. And I want to draft the picture before showing you where we are going to. And I have this to be north. Then 80 degrees should be somewhere here now. Is it not true? Then let's say this is like 10 degrees. What we are saying is that this wind does not actually move out this way. Rather, it is coming from this position. It is coming from this position. That is from north 80 degrees east. It is coming from this angle. The angle is where it's coming from. As it's coming from this angle, where is it going to move to? This is the angle it's coming from. This is the wind. It's coming from here. So likely, where it will move to now will be determined by its bearing. So it is having a bearing of 080 degrees. So it is going to go in the opposite direction. So if it's going in the opposite direction, all I need to do is to say, will it go up here or down here? Why will it go down? Reason being that I cannot count, I cannot count out 270 and then start counting this 360. So I must attend to this first, since I know that it must go in the opposite direction. And even when you learn this very well, that when it starts from a place, automatically looking at this is already telling you where it will go to. So this is the angle. What this thing that you have here is just telling you is just that the angle that the wind is coming from is from this angle. It doesn't mean that the wind is pointing out this way. What it's telling you is that it is coming from this angle. That is what it's trying to tell you. It's coming from this angle. And then it is now going to be heading from that angle. It's going to be heading, and notice something. Now, using that our principle of what's it called? Vertically opposite angles. You can see that 80 degrees that is here is now opposite this one. Is it not true? Yes. And this 10 that is here is not opposite this one. Is it not true? So even without us trying to do that our mathematics, once you hear from, what that from is just telling you is just that that angle is what you are taking note of. So if I've taken note of that angle where it is going to move from, whatever it is facing, that's where it will go to. Are you understanding this thing now? Very important. So, with that said, you see that it is not the same thing as saying if I come and add that 180 plus 80, everything from this way to this way gives me 260 degrees. It's even of no use trying to show this 260 degrees, because I normally tell my students, whenever you are considering anything you're dealing with angle, always think of it this way. This side's 90 degrees. This side's 90 degrees. This side's 90 degrees. This side's 90 degrees. Equilibrium. It's best that way. Even when you change at the full angle, you might enter and do mistake. So each side is 90 degrees. It's equal. That is where you get this. So with what we've gotten now, we can now just come and peacefully redraw this thing. So that I now have, looking at that, I can now peacefully draw. I can just come and say, I have this, I have this. I say when it's wind, the angle is just telling you where you are going to finish. You remove yourself, you now know it. Oh yeah, I can now come and peacefully draw. I have this side, just my vertical and my horizontal to make use of it. So I have this thing to be 60 degrees, shall we? Then I have this one to be 10 degrees. Do you remember that I said, once we are not treating simple pendulum, and inclined plane, angles inclined, or should I say angles at an inclined plane, relative motion. We are dealing with relative motion, I hope you know. But this one is more like a relative motion associated with vectors. If you look at it, it's already taking us to resolution of vectors. So I told you, whenever we are dealing with vectors, that we should try, it's not like we can't use vertical angles, but we should try and make our angles to be with the horizontal. Do you still remember? We said something like that. But if you use with the vertical, you still get it. But it's just that's the essence of you being in class. So please, if you feel like you are tired, you drink water. Yes. I notice. I'm teaching. Oh, now what are you doing with your head? Please, this thing is not hard though. See what I said. If it's wind, in fact, if the understanding is hard for you, see it this way. If it's wind, they give you an angle. Go and find the vertical opposite angle. Can you hear me? You can write it down. If it's a wind, know that whatever they tell you is the opposite. You are going to be going to the opposite direction when it's wind. So you can find the vertically opposite angle. Those are the things we did here. So we've tried to do it in different ways. So once I've done this, I'm not taking the angles with the horizontal at this side. If you notice, 10 degrees is the angle with the horizontal at this side. This is horizontal line now. 10 degrees is the angle here. Now 60 degrees is the angle here. So I've taken the angles with the horizontal. Then the next thing is to now do my resolution of vectors. So I will simply say the velocities. Remember the formula I gave you for resolution of vectors. It is simply the vector. In this case is velocity. Then the x-axis and the y-axis. This is your formula for resolution of vector. What is the formula? Just a table. A table that talks about the definition of resolution of vector, which is the splitting of vector into the x and the y components. So I've gotten this. I have 100 kilometers per hour, and even is of no use doing this because I can just come and say the velocity. That is why you do practical, to learn all these things. And just say this is kilometer per hour. You finish there. then I just come and write 100. Then I come and write 30. So when I'm taking this 100 to the x-axis, notice, this is the one for 100 kilometer per hour, and this is the one for what? 30 kilometer per hour. So if I'm taking 100 to x-axis, what do I do? Am I closing the angle? It will be going towards the angle now. So it will be 100 towards the angle is what? Cos theta. So, and the angle there is what? 60 degrees. Now, if I'm taking this angle to y-axis, what will I do? But let's check something, Shebi. This is south. South is what? Minus for y now, Shebi. But everything x here is what? Okay, so now, if I want to take this thing now, this 100 to y-axis, am I opening this angle? I'm leaving this angle, Shebi, you know.
Yes.
So away from the angle, use what?
Sine.
So 100 sine 60 degrees. Okay. Now, if I have this 30, where is Isaac Newton? Is he here? Okay, he's not in class. Okay. If I want to take this particular side, now notice this side, what is x on this side? Go and put it. Sometimes you might forget. Go and put the minus. And this down here, what is y here? Go and put it so you don't forget it. Oh yeah. If I'm taking this 30 to x-axis, am I closing this 10 degrees angle? So I will have towards the angle what? Cos 30 cos 10 degrees. Oh yeah. If I'm carrying this 30 degrees, 30 kilometers per hour to y-axis, this particular angle here, am I opening it? Yes. So I will have minus 30 sine 10 degrees. Do you know some people's problem? Why did the man now abandon this angle? And he abandoned this one. Why is it? Please, always abandon your own. Reason is that we are saying always make angle with the horizontal. Whenever it's vector we are doing, just make angle with the horizontal. You don't stress yourself. Just find a way to make the other part of the angle. Whatever you have for cos 80 degrees will be the same thing for cos 10 degrees. Are you getting it? Just abandon it. So if that be the case, do for me 100 cos 60, what do you have? 100 cos 60 punch. 100 cos 60, you got 50. Oh yeah. Minus 30 cos 10 degrees, what do you have? Minus 29. 0.5. 4 what? Okay, 4.2. Shebi, you remember that we said don't approximate until final answer. Oh yeah. Minus 100 sine 60. Oh yeah, do for me. Minus. Minus 36.025 like this. Okay. Okay. On your punch for me, minus 30 sine 10 degrees.
Minus 5.209.
209. Okay. Just always approximate to 4 decimal places, and that is it. Oh yeah, now see what you now do for me. At this junction, I can now say. Wait. I can now say, let me sum up the forces, the velocities on the x and the y axis. So now do for me 50 plus minus 29.5442. Punch for me. $20.455. 4, 5. Like this. Okay. What do for me? Minus. We are trying to sum up. Minus 86.6025 plus minus 5.2094. Hope you understand. Are you understanding what I'm doing? Yes. So I'm trying to sum up these two. Minus 0.8. Okay, like this. Okay. Do you know what I've succeeded in doing? Please, I said, note all the things I'm saying if it's hard for you to start from beginning to remember it. I said, when it's resolution of vectors I'm doing, I just say, that vector I'm talking about, if it's velocity or a force, get the x-axis component, get the y-axis component. I now said, when it's a wind I'm treating, just check the angle I'm giving. If I find the angle I'm giving, find the vertical opposite side of that angle. That is what you're using. So if I have, for example, 90 degrees north, I should be using 180 down on the south. If I have 0 this way, I should be using 180 this way. Is it not? This way now? Yes, angles on the straight line. So please use that concept if it's hard for you to remember or to start from the beginning to think about it. Can I clean? Now let me show you why they failed it in your notebook. Your notebook did the tan rule. That's your solution in your workbook. The tan rule they did tan theta equals to x over y. Instead of tan theta equals to y over x. Hope you remember that tan theta tan rule is y over x. Are you aware? Yes. Check. When you do it with y over x, you will get around 70 something. But your textbook, your workbook got 160 something. Do you know why? Whoever solved your workbook, I've noticed it with a lot of similarities, really used ChatGPT. And a good number of you like using ChatGPT. Yes. So any mistake ChatGPT made, the workbook made it. And guess what? Most of you, your own is copy it. Even when you handle that book, you copy. You type what the thing will go. Some people will just snap it, even laziness. Typing is too much. They will just snap it, go and post it on ChatGPT. Oh, yeah, answer. They copy it. So if you try this thing now, by the time you do the tan rule, you'll see that what you get for y over x will be different from what they did here because they did x over y. So let's solve. Let's see. Okay, ask me.
Please, I don't know if I'm mistaken, but in your last class, you were mentioning something like minus two vectors.
I will go there, I will go back there. But please, did you understand this one and that one? I will explain, don't fear. Oh yeah, see, do you remember tan theta? Let's just finish this. I'll throw like tan theta is equals to y over x. Shebi? Which means that theta will be equals to tan inverse of y over x. Please, the idea of using resolution of vector is simply taking single vector to the x and y axis so that you can be able to use the tan rule. That is why I told you, anytime you have resolution of vector, it is easy for you to know it that when finding the angle, you just simply use the tan rule and get your angle. So I will now have theta is equals to tan inverse of, I check, what's the y? I will not put that minus. Hope you know we don't put minus for angle. This minus is only showing me the direction. See what this minus is trying to do for me. I know that here, plus, look now, look, here, plus. In this quadrant, we have plus x and plus y. Now here, plus minus should be, and x always comes first. I have minus and plus. Y here I have minus. Then here I have plus. X always comes first. So this is plus for x and y minus. Which is why I told you that if you see a question that says maybe they give you something, they tell you two vectors. They tell you 2 and maybe 4. The first one means what? The second one means what? Without even them giving me x and y. So any other three thought, if they have any thoughts in there, it means the K part, that is the Z part. So if I know this, now ask yourself, in what quadrant, Shebi, you know this is positive. In what quadrant do I have X to be positive and Y to be negative? Is it first? Which quadrant do I have? This is first now, second, third, and fourth. So in what quadrant do I have in what quadrant, we'll still prove this thing when we start doing trigonometry. In what quadrant do we have X to be positive, Y to be negative? Fourth quadrant. So what this thing is just telling you is that the angle, that the track is on the fourth quadrant. Finish. That's the track. And do you remember that your plane is actually moving in this fourth quadrant when we drew this thing? Should you still remember? So please, that is just what to show you. Don't go and be carrying this thing and be doing minus in your angle. It's wrong. So I will simply have 91.8119 all over 20.4558. Punch for me, what do you have? Just this one is what? Divide this one, just this one is what? Tan inverse of what? 4.4883. 4883. You see what you have? Yes. Oh, yeah, do for me the tan inverse. See that will be what? Punch now. 17. 17.4. Like this. 39 what? And this is the center theta is approximately 77 degrees. Oh, yeah, check for me. Do for me this thing. Just one question. I will explain and explain and explain. See. I'm not starting from the beginning. I just want us to check something. See. I got. Hello, see. A bearing. The northern part of a bearing is what? Or. Wow. The eastern part of a bearing is what? You're not saying anything. 90 or what? Hope you know that if I get 360, I'll do 360 plus 90 is what? 360 plus 90 is what? This is also 450. Now watch. If this is 90, this is 180 degrees. Since you people don't want to learn it in small, let's not make you run mad. Since it's like that, you want to see. Watch now. Watch. This is 180 degrees, Shebi. 450 plus 90 is what? 540. This is also 540 degrees. Watch you. Now, if this is 180, this side should be 270, Shebi. Or 540 plus 90 is what? 630. Is this 630? Check. Oh. Yes. Okay. Now see, I'm stopping here. Now notice, I can still do 630 plus 90 and get something else for this. Now see what I'm saying. If I know that it is on the fourth quadrant, I have X to be positive and Y to be negative. If I know that, it means that anything I get for that 77 degrees is actually here. But notice, we are talking about bearing. The bearing should run from 0 to this. So when you now do this our bearing now, and you come and do 90 plus this 77, you punched it and it gave you 160. What? Let me write 167 here. Now, please check for me. Where did I start this angle? Shebi is from the north. So I will have north. What do I have in between this north and this? 167. Shebi? Now watch. No, watch. This angle now that I'm seeing, did it enter? Where is it running to? South. Watch. This thing now. Shebi, you see, it has crossed the east and tending towards the south. Are you seeing it? I will come and write S. If I want to call this thing 77 degrees, it simply means that what I will say is E 77 degrees south. Now, there is also another angle remaining here. Shebi? And that angle remaining here is when I do, the whole of this angle is what? 90 minus this 77 is what? That means that this angle here is actually 13 degrees. Now this is south, Shebi. This is east. This one is starting from south. That means that I have S 13 degrees going towards where? East. All these things are my track. It's not up to me to know the one I'm choosing. Are you there? Somebody now said, what if the three of them are in the option? If the three of them are in the option, the right one to choose is E 77 degrees south. Please, before Shavita said charity begins at home. Is it not true? This thing now is actually this environment where this thing is happening. Are you aware? It's on this quadrant. So if you are considering the fourth quadrant, everything happening here belongs to the fourth quadrant. That is where it's happening. That's the whole. So when it now wants to be beautiful to environments, general community, extended community, that's where you're now including all these ones. Including all these ones. In fact, this particular one to this 13 degrees is also there. And this one. So this one should be my last option. This not 167 should be my last option. But if you are not considering generally that we are dealing with bearing, and remember please, 77 degrees is actually in bearing, 077 degrees. Do you still remember? Yes. So, okay, what?
That is 77 degrees. How did you know that it was next to your last?
This person keeps waking up. Have I not explained this thing before? One question. 2 hours. See, but wait, see. What quadrant? This thing has been positive here, negative here. What quadrant is it? What quadrant is? When do I have X to be positive, Y to be negative? First quadrant, Shebi? Yes. So if I draft, please, we are moving to the next question, but let me finish it. If I draft this thing now, where is the first quadrant? If I call this first, second is a constant. That's how you do it. Third and fourth. Where is the fourth quadrant here, Shebi? That means that 77 degrees angle I got actually falls here.
You mean that you must have something?
Yes. Yes. So you must start it from this point going down. Remember we are dealing with bearing, Shebi, you know. Do you still remember we are dealing with bearing? And bearing runs from this way. Assuming it's your circle we are dealing with, you cannot be considering any other thing. But please, whenever it has to do with finding angle on a quadrant, if it ever. Oh yeah, question 2, please.
So what's the answer?
What's the answer? Name the answer now. See, these are the answers. Ground speed. Okay, we've not gotten the ground speed. Okay. I'm using Pythagoras theorem. Let's do something. Using Pythagoras theorem. Oh yeah, recite Pythagoras theorem for me. He's alright. He's alright. Some persons are wondering what you are doing. How did they even get this one? You know there are people that went to secondary schools that God knows how. But now you're in the university. Fear not. Please. Let's do this thing now. Let me have, if I take the square root of both sides, please, that your, what's it called? That your textbook, workbook, where you solve your own, you put 77 degrees, 077 degrees for me, the way I put it. S 13 degrees, the way I put it. Before you put your N 167 degrees south. Very important.
But this 13 is supposed to have 0.
It's the same thing. 0. Explanation want to keep is wrong here. So this will cancel this. So R is equals to, what do I have on the X? X is 20, Shebi? That is on the X now. X axis is 20 points. You know that there's no need putting the minus, but let me put it, yeah? There must be a difference between you and regular students. Deacon, don't do if you solve your own. You can put 167 only. The year those you never. The year like that. Oh yeah, punch for me. Do for me 20.4558 square. What do you have? Eh? 41.43 like that. Any other thing? Okay. Plus minus 91.8119 all square. What do you have? Should be on head disappear go. Okay. You people are disappearing. If I come back, people will disappear. I will soon disappear my own. You don't know you're supposed to eat before coming. Minus 91. 842. 0.42. Okay, 4249. Yes. Yeah, I want it like this. So. Ask for me. That approximation, let it not go beyond 4 decimal points. So 418.439 plus 8429.4249. Add it up. Remember tomorrow, we have practical class. Saturdays is for our practical class. We are going to be doing stroke slow tomorrow. 0.39 like this. I'm going to take the square root for me. 94.0630. Okay, which is approximately 94. Hope you know. And remember that what we are dealing with is velocity, Shebi. That means this will be in kilometer per hour. Please, remember I said, anytime they tell you ground speed, they are asking you to use Pythagoras theorem. Can you hear me? Is either anytime they tell you to find ground speed, what they're asking is to use Pythagoras theorem or to use this thing. R square equals to x square plus y square minus 2xy cos 180 minus. You can take the formula. So it's more like ground speed. If Shebi, you know that this formula is the same thing with this formula. Just that this one is when the angle is 90 degrees. Cos 90 is 0, Shebi. 0 times everything here will be 0. So you are not left with just the Pythagoras. So the same thing. So anytime ground speed, anytime track, they are telling you to find the direction. The track. Oh yeah, question 2. There is no time. Or look at the question. Even if it's not question 2, look at the question. Which one looks one kind to you there? Please, key details to note the way we presented our answer. Another key details to note, whenever they say wind, find the angle vertically opposite. Another key details to what we are doing is, when we are talking about relative motion, how do you know it's relative motion? You will notice that it's not just, maybe they are talking about one object moving. Very soon, from next week, what we'll be doing is all about motion. Ngwasi, I want you to check for me. There's a question that has something like inclined plane there.